Hello students, welcome to my channel CGAT Maths. Myself, Dr. Suresh Biradar, Associate Professor, Department of Mathematics, Chandbasva University, Kalburgi. In this video, we are going to discuss an example based on homogeneous partial differential equation involving a derivative with respect to one independent variable only. Independent only. Okay, so look at an example. Solve dou square z by dou x square plus z is equal to 0. Given that the condition x equal to 0, when x equal to 0, these two are satisfied. Or you can also write that when x equal to 0, z is equal to e raised to y, and x equal to 0, dou z by dou x is equal to 1. You can write in equal to 0, then dou z by dou x equal to 1. Okay, fine. Look at solution is very simple. Look at this is a partial differentiation or partial derivative which is with respect to one independent variable x. So whenever a partial differential equation which involving a derivative with respect to one independent variable, it will become a ordinary differentiation, d square z by dx square. That's all. Plus z equal to 0. Now this is very simple. This is like a homogeneous differential equation in case of ordinary differential equation. So here I am going to write it as a d square z plus z equal to 0. We know that d square is equal to d square by d small x square, or this is d square plus 1 into z equal to 0. So now what is the auxiliary equation here? Auxiliary equation is m square plus 1 equal to 0. Auxiliary equation is obtained by replacing d by m and neglecting remaining thing. So if m square plus 1 equal to 0, m square equal to minus 1, or m square or m is equal to plus or minus square root of minus 1, or simply plus or minus I. If roots are plus or minus I, then solution z is equal to dependent variable is equal to, since roots are plus or minus I complex and it is purely imaginary, means which is c1 cos independent variable is x, c1 cos x plus c2 sin x. Here the derivative is with respect to x. Here independent variable is x is showing, but the y is not appeared here. Okay, so it is defaultly, actually you have got z means you have integrated d square z by dx square plus z equal to 0 twice. You have got this, but unknowingly you have done a integration. Okay, so z is equal to c1 cos x plus c2 sin x is the solution of this equation, but we need to replace the constant c1 and c2 by function of y here, f of y cos x plus g of y into sin x. Means the meaning that you have integrated with respect to x, but here we need to replace the constant c1 and c2 by function of y. Now let me substitute these initial condition in the next slide. So z is equal to you have f of y cos x plus g of y into sin x. Fine. Now what are the conditions you have? When x equal to 0, when x equal to 0, z is equal to e raised to y, and when x equal to 0, dou z by dou x is equal to 1. Okay, so let us differentiate this side by side. Okay, differentiate this with respect to x. Okay, what will happen here? F of y remains as it is. Differentiation of cos x becomes minus sin x. This is minus f of y into sin x plus g of y as it is. Sin x is cos x. Now let us use the conditions. By conditions, conditions are, first condition, when you substitute right side x equal to 0 and left side z becomes, okay, by conditions, okay, when x equal to 0, z becomes e raised to y and dou z by dou x becomes 1. Look at carefully. Z becomes e raised to y. X equal to 0 means you have f of y. Cos 0 is 1. G of y into sin 0 is 0. Look at in the second one. Dou z by dou x becomes 1. This is minus f of y into sin 0 is 0 plus g of y into cos 0 is 1. So second value is 0. Here you will get f of y is equal to e raised to y, and here g of y is equal to 1. Therefore z equal to, or z becomes, on substitution of f of y and g of y value, f of y value is e raised to y cos x plus g of y value is 1 into sin x. That's it. Thank you so much for watching.